In this video, we're going to take a look at Hadoop in the cloud using AWS Elastic MapReduce. We're going to define what EMR is, how EMR compares to Hadoop, and look at several use cases where EMR may have an advantage over Hadoop. First up, EMR, like everything that Amazon Web Service offers, is a service. Before you even consider using EMR, it's helpful to review what Amazon Web Services is. And to this end, Infinite Skills offers a course that I actually delivered myself. It's available at this URL, which is also available in the appendix. Amazon is constantly changing and evolving. It may be the only technology I know that moves faster than even Hadoop itself. You can always find the most recent, up-to-date information at this URL. EMR essentially abstracts out the cluster setup and management. It has integrated provisioning, tooling, debug, and monitoring. Amazon is constantly tuning and optimizing it. Anytime a node fails in EMR, Amazon automatically reprovisions a virtual machine to replace that node. EMR can also be a whole lot more cost-effective to run. The clusters automatically shut down by default once you're finished doing the processing. This can obviously be excellent for sporadic MapReduce needs. If you only need to process data maybe 2 to 6 times a month, EMR may be your best solution. Obviously, it has tight integration to AWS services. You can leverage cost-effective EC2 instances for processing and S3 for storage. Because the EC2 instances come in a variety of types, you can get the specific memory, CPU, and disk storage requirements that you need. Monitoring can also be done via CloudWatch. EMR has an architecture that's slightly different than what we see with core Hadoop. It essentially uses what it calls instance groups, and it has 3 of these. The master instance group controls the cluster. You can think of it as you would the master nodes in a regular Hadoop cluster. There's also a core instance group, which has EC2 instances running data node and task tracker daemons. This is what provides the HDFS storage. There's also a task instance group, which provides processing. Unlike the core instance group, which must be static and cannot change after you start the cluster up, task instances can be added and removed based on your storage needs. It's very common to see S3 used for both the data input and output. The instances in the master group coordinate task activities and manage the cluster state. In addition to reading data from S3, the master, core, and task instance group then write all of their derived data back into S3. Obviously, being an AWS service means that EMR integrates tightly with all of the other Amazon services. You can, for example, pull and push data to RDS or to DynamoDB, as well as S3. The derived data can also be stored back in Redshift, the OLAP processing engine that Amazon introduced in 2012. This is accomplished via AWS data pipelines and can, for example, be used for further post-processing. Data can also be pre-processed with Kinesis. Before you even get data into your cluster, you can have Kinesis pre-process it to maybe make your cluster work a little less. In exchange for the convenience that you get with EMR, you obviously give up several things that are common across all Amazon services. Front and center is control. EMR is always going to be 2 to 3 months behind the Hadoop releases. You also cannot use CDH or Horton Data Platform releases, although MapR is supported. You may have slower running speed. If you're not an AWS customer already, your job may actually run slower because of the time it takes to load your data into S3. Although it's not super tight, you do have a little bit of inconvenience with vendor lock-in. If you put all of your data in S3 and then you decide you want to go somewhere else, you would have to pull all of your data back out of S3. EMR does really shine in a handful of use cases. It's obviously very convenient if you're already an AWS customer and you have a lot of data already stored in one of their data stores. As we said before, if you have sporadic MapReduce needs, EMR can get you up and running much quicker at a much lower cost. Either EMR or core Hadoop running on top of AWS instances, as we see in our Cloudera Manager exercise, can be a great way to proof of concept or test drive Hadoop before installing your own private cluster. Obviously, it's also very easy to use because it uses EC2 under the hood. It has seamless, near infinite scale with regards to how big you can get it going, and it has a very simple administration user interface. Again, taking away a wee bit of the control in order to give you a whole lot of convenience, as we see with other Amazon Web Services. We've covered what EMR is, how it compares to Hadoop, the benefits and downsides, and several use cases.